Welcome back. This is video 4 on arrays. The focus of this video is in two-dimensional arrays. A two-dimensional array looks like this. It consists of rows and columns of information. It's normally a rectangular shape with a certain number of rows. In this case there are 4 rows, and columns, there are 4 columns. So we would say this is a 4 by 4 two-dimensional array. In C++, the way that you declare a two-dimensional array is to supply 2 sets of capacities. The array name is A, and it has 4 rows and 4 columns. If it had 5 rows and 2 columns, you would say 5 in square brackets, 2 in square brackets. The first set of brackets identifies the number of rows, the second the number of columns. To initialize the variable A to what you see in the array here is you must provide the values for each row as a separate set. So we see an outer set brace, open, close, and inside of it we see the values listed for each row. 1, 7, 2, 4 for the first row, 7, 5, 2, 9 for the second row, and so forth. As we said earlier, an array gives you one name A, multiple values. In this case it's 4 times 4, or 16 values. Each of the values, there's a variable that corresponds to each of the variables. The variable that corresponds to the first element of the array is, listen carefully, is A sub 0 sub 0. You must say the word sub twice. What about this one? This is in the third row, but row subscripts start at 0, not 1. So this is subscript 2 for the row subscript. This is which column? 1, 2, 3. What's the subscript for the third column? Is not a 3, but it's a 2. Similarly, the last array element is A sub 3 sub 3. Now we're going to look at some code for doing some things. Alright, so let's look at the code that establishes an array. Okay, now often people use the word two-dimensional array and table in the same sense. Technically that's true only if all the columns and all the rows contain the same type of data. Remember, an array is a collection of data, of all data of the same type. Alright, so this is how we declare a 3 by 4 array, and here are the values. And now we're going to display the values in the array. When we display them, we expect 3 lines of output. One line contains the values in the first row separated by a space. Alright, and so how do we do that? Well, we must display the values in this row. What row is that? The first row has what subscript? 0. Then we display the values in the second row, which has subscript 0. Then the values in the third row, and the row subscript is a 2. So basically we have a nested loop. Remember I had told you earlier that when your data looks like it's two-dimensional, then you need a nested loop. In this case, if we're going to output things row by row, the outer loop is based on row. So the inner loop must move across the columns once you lock into a row. So the inner loop is by column. And in this case, the column subscripts are 0, 1, 2, and 3. For the outer loop, the row subscripts are 0, 1, and 2. So this is the loop for producing that. What is the rule? If I have a two-dimensional array and I must visit all the elements in the array, I must have a nested loop. There are times when you will be told to do things column by column or row by row. So you have to pay attention. Alright, so let's go ahead and run this program. as you see, we're producing the output. We're producing the values in the array. And you see how that relates to the code that we have up here. All right. Now let's do another problem. This time, let's go ahead and build a function. Use functions for the 2D array. What we want to do here is we want to take the code that we had written for displaying the array and make it the body of a function. So let's talk about the function. If we look at the header of the function, we have the name show a 2D array. And if I want to show an array, I must give the function the array to display. So how do you indicate that you're giving it a one-dimensional array? Well, if you were giving it a one-dimensional array, you would stop at the first closed square brace. And that would say you're being given a one-dimensional array. The rules are a little different if you have a two-dimensional array. If you have a two-dimensional array, in the first dimension, that is the number of rows, you leave it blank as before. But if you have columns, you have to put the number of columns there are in the array, because that helps tell what the shape of the array is. So technically, this function ought to work for an array that's n rows by 4 columns, as long as it's a 4-column array. So we're going to print out a heading, and then what kind of loop do we need? Same as before, a nested loop. Rows come first, this outer loop. Column is the inner loop. Okay? In this case, we know that this function is made specifically for the 3x4 array, so we know how many rows and how many columns. If we generalize this function, we would of course make it work no matter how many rows you have. So what does the main look like? It looks like what it had before, and then now instead of having the code right here, we're making a call to the function. So let's look at the header of the function again. And what is it telling us? The header of the function says I must pass it an array, a two-dimensional array that has integers and 4 columns. We have such an array and its name is t. So what do we pass? We pass the variable t. Does the definition of the variable t match what we are given in the header? And the answer is yes. It's an int. It has a name. It has a set of rows, and we say leave the number of rows blank, and it has 4 columns. Put the 4 here. So the variable t has all the properties that you see. So when you make the call to the function, put variable t. Is it clear that when I make the function call, it's too late to try to declare the variable t? The array variable, you should already have it. So this function should basically produce the same output as before. So if we run it, what do we get? We get basically the same output. All right? Now the third thing we're going to do is write one more function, and this function is going to calculate the maximum value in the array. And let's take a look at what the array looks like. It's kind of hard to see now. The array is what we had before. This is the first row, the second row, the third row. Our algorithm is going to say start with the first row, compare this to the max, this to the max, this to the max, this to the max, skip to the next row, this to the max, compare this to the max, this to the max, this to the max, and so on. So it requires that we visit every element of the array. So what's required? We have a two-dimensional array. I must visit each element, so I need what type of loop? A nested loop. In solving this problem, we can either go row-wise, row by row, or we could do it column by column. Doesn't really matter. All that matters is that you visit every element. Remember we said finding the max is an accumulation problem. An accumulator simply means as you go through your steps, you have an answer so far. So the key to having an accumulator is to start off with the right value. When you're trying to find the max or min of an array, the best way to get started is to set the first element of the array to the answer. Because when you hit the first element, that will be the answer so far. So we're setting max to the first value in the array. Now let's look at the header real quick. This is a void function, so when I call it as a statement. It does not return a value. Well, how do you get the answer back? Well, you get the answer because when you call it, you must give it a variable. Ampersand says when you call it, pass a variable. So in the main, I have the variable biggest. I have declared it. Its role is to hold the answer once I find the max. Okay? So this variable is passed to you by reference, so we don't need to declare it again. It's already declared. We set it to the first element. And now we can go through each element of the array, and if the maximum so far is less than the element I'm looking at, then I set max to the element that I'm looking at. Okay? So let's take a look at what happens when we run this. Okay? So when I run this, I'm calling two functions, one to display the array and I see all the values, and one to call find max, and we see that it's returning the correct answer. Right? You can play with these programs that I have shown you, and and you can play around with having different arrays in that to convince yourself that these functions are working correctly. With that, we're going to terminate this video.